Look at this. Oh, not that. Don't look at that. Look at this. It's September. Look at that. Just like that. It happens. Are you guys all excited for the early release Friday to go out and watch the football game?
Also, yeah.
No, well, hold on. Let me pause this real quick. Anyhow, starting today, we're going to start factoring. They're called lookalikes. They're not actually called lookalikes, but that's what I call them, and that's what I would think that most of my students wind up calling them. The technical name for them is they are called quadratic form. I just think it's more fun to say lookalikes. So let's just dive right in and take a look at what a lookalike looks like. So I don't have to ask you condescending questions that insult your intelligence, uh, like, what do you notice? Because clearly you're like, whoa, we've kind of upped the game here a little bit. So this is not like anything we've seen before. This is a fourth degree polynomial, and factoring it is actually not that bad as long as you understand sort of the mechanics behind what's happening. So the reason we call this quadratic form is because it's essentially identical to this. And you've been hanging around with me long enough to know that the red one is just a simple quadratic, like absolute simple, right? So if we were going to do the red problem, we would factor it down into shells like this. You should have done, I mean, I can't even tell, 50, 80 of these by now this year, just a simple quadratic trinomial. And if we factored it down, we would put m's. And then, of course, we'd know that we need one of each sign to make the negative on the 24. So we're going to put one plus and one minus. And what are the magic numbers? Correctamundo. And again, having the experience that you have, you know to put the six next to the minus because you want to give it strength of negativity, right? So the six would go with the negative and the four would go with the positive, assuring us that we get negative six and positive four so that when we add, we of course get negative two, right? So to have this make absolute infinite sense here in about 30 seconds, you're going to be like, oh, this is easy. And that's a great thing to say. If I were to change this, so watch for yellow on the board. If I were to add a two here and a two here, I'm going to erase this now. I hope you agree that if I were to buff each of the m's and turn them into m squared, I would accomplish a really cool mission. That is, let's take a look at these yellows. What happens when I multiply those yellows together? What do you get when you do m squared times another m squared, which is exactly what we wanted. And I know I switched variables, but it's an old math trick where we substitute out letters to make sure you understand differences. But look, we did it. We made a fourth. And we're going to skip over the m to the third because there's no opportunity in what we have in our parentheses for m to the third to ever exist. So let's take a look at the purple two on the outside now. What do the two outside ones make? Negative 6 m squared, right? And what do the two on the inside now make? Plus 4 m squared, right? So if you take those two yellow things that I just wrote and you add them together, what do you get? These two in the box. You get negative 2 m squared. When you add them, right? When you combine like terms, negative 6 plus 4 is negative 2. And then, of course, we can do the ones on the back. I'll use, I guess, green for this. We knew this already. What is 4 times negative 6? And there you have it. So by buffing the parentheses, so by buffing those m's, we've enabled ourselves now to create a lookalike. That's what this thing in the yellow is called. That's a lookalike. And again, it's in what we call quadratic form. So it's not a quadratic. You get that. A quadratic has x squared, not x to the fourth, right? But it's in quadratic form. And the way you guys are going to recognize quadratic form is with a pattern. And I'm going to use white over here because I vandalized this to the point where I'm almost out of colors. But take a look at what the things I'm putting in boxes. What would you say is the pattern in the exponents in the white boxes? Bless you. What would you say is the pattern?
Multiply,
Say again?
multiplier.
Yes, study the pattern from left to right. Tell me, I don't disagree, but just study what would you describe the pattern as from left to right? Take the white boxes and go ping, 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 left to right. What would you say they are?
They happens now.
They half. Yeah, I mean, and technically it doesn't really work that way because half of two is one, but I get what you're saying. So the pattern goes like this. You can recognize a lookalike if the first exponent is even. If the second exponent is half as much and the third exponent is zero. There are no variables in the third term. The moment you recognize that pattern, then you have yourself a lookalike. And how you attack a lookalike isn't fundamentally any different than how you attack a normal quadratic. So you may be sitting here in one of two camps. Either I get this, shut up, let's move on, or I have no idea what this man's talking about. Let's head over to the white polynomial on the left. The moral of the story is this. When I put a lookalike like this in front of you, your job is still to do shells. It's in quadratic form. Lookalikes are quadratic form. But when we build our shells, we're not trying to make x squared. We're trying to make x to the fourth. So we divide it by 2, place half of them here and half of them here. And then the same rules apply. If the number in back is negative 24, then I need 1 plus and I need 1 minus. And I'm still just back to the old 8th grade, 6th grade times tables. I still want a 4 and a 6. And so I'm going to put a 4 here and a 6 here. And that is how you factor a lookalike. If they all were that easy, this lesson would be about 4 minutes from over. I would give you a couple more examples and we would be like, boom, done, moving on. So as you're going to see now in the next 1, 2, 3, 4, 5, 6, 7, 8 examples, they're not always quite that simple. Okay, sometimes they are. And I'll come back to pointing out why this one is simpler when we see the next example that's not quite as simple. But remember this, keep it there right below it in your notes. Let's write the next problem, which is this. I'll switch colors here. Let's do red. No, I'm not having like a stroke. I did not give you the same problem twice. I gave you a very similar problem, but very much intentionally to show you how subtle differences can make problems more difficult. So here you have your second lookalike ever. You can recognize it as a lookalike because the exponents go 4, half of 4, 0, right? So when we build our shells, what are we going to put in the beginnings of our shells? X to the second. Again, if you didn't get the memo, you take the first exponent, divide it by 2, and then put half in each. So like if it were a 10, which you will see at some point, then you'll put x to the 5 and x to the 5. You divvy it up equal, right? Splitsy. So we're going to go x squared in the first, x squared in the second. Everybody got it? And again, I'm looking now fundamentally for a positive and a negative. So I'm going to put one of each in. What changes this time? Right. This time I want the answer to come out. Let me draw a little wall here to make sure we're clear. This time I want it to come out plus. So I'm going to put the 6 with the plus this time to give it more strength on the positivity side and put the 4. And you might say, well, that feels exactly the same. Here's where this class is about to become more difficult, is that you're not done. And I alluded to this last week, and I think I even kind of gave you a specific example like a full week ago that sometimes you factor and you're not done. And you're going to start to see problems where 2 steps might be required, or as you'll see in today's notes, 3 steps might be required. But in this case, can anyone see why it's not done? It's very important that we have this conversation about why is this one not done, but why was the white one above it done? Do you see anything? I mean, welcome to the next week of your life. This is going to be huge. So I'm going to underline something for you and ask you a question. What is that? This is where it becomes important that you and I use math language to communicate. I'm not a big vocabulary guy, but I need you to say out loud, oh, that's a difference of two squares, right? That becomes your job, is to recognize now that the offspring themselves can create offspring. And so that x squared minus 4, we know from our first quiz, is its own factorable expression. It's not dead. X squared plus 6 is what we call a dead factor. You can't factor x squared plus 6. Done. But x squared minus 4 becomes now its own cute little math problem that factors itself. So I'm going to underline in white the two things that are the same. Underlined in white above is the difference of two squares. Underlined in white below are the two factors of x squared minus 4. What are the factors of x squared minus 4? How do you factor a difference of two squares? You, you don't divide it by 2. That's really important. We're not dividing here. If I gave you k squared minus 144, that's a difference of squares. It would factor into k plus minus square root of 144 square root of 144. Does that ring any bells? If I gave you 4y squared minus 25, that's a difference of squares. It factors into square root, square root, square root, square root. One gets a plus, one gets a minus. Having reawakened that part of your memory, could you now tell me what are the factors of x squared minus 4? X, 2, 2, plus, minus. Difference of squares is not one of those things that gets you through one quiz. It's a fundamental thing that will be either the reason you survive a lot of math problems this year or the reason, quite frankly, that you struggle to pass the class. It's imperative that whenever you see one of those little turkeys pop out, that you recognize it and go, I know you. You're a difference of squares. And the same you'll see in another example is going to be true of cubes. If you can't recognize a sum or a difference of cubes, prepare to be on the struggle bus. Having said that, those two are the offspring of that one. However, x squared plus 6, having been a dead factor, needs to get copied down. Basically, the x squared plus 6 is just going to stick around like a bad cold. In any problem, as these get more and more complex, anytime you recognize a dead factor, it just stays with you as you do the subsequent steps. What's in the white box is the final answer. Got it? Let's go again. So there you see a really classic example of two quadratic lookalikes where one creates two dead factors, whereas one creates more offspring. I said I was going to talk about this. Follow the sort of purple connector here. Between these two, at the end of the big weird purple arrow thing, why was the one up at the top of the TV dead, whereas the one at the bottom is not? Since you're not talking to me a lot, I'll just keep asking you questions until you start talking more. Is x squared plus 4 factorable? It is not, because with squares, you can only do it with a minus. And this will be something that people are still messing up in the middle of October. Just you have to decide if you want it to be you or the kid sitting next to you. X squared and 4 are tempting. Like, ooh, that's one of those difference of squares. And then you go, no, it's not. That's not a minus sign. That's a plus. So despite your greatest intentions, x squared plus 4 cannot be factored. And what about x squared minus 6? It fits the mold. It's got x squared and it's got a minus sign. Why can't I factor it? Because 6 is not a square. Can't call something a difference of squares if it's not a difference and it's not built by squares. So that's why the one I've underlined in green is dead, done. The one below was not. On we go. Next one is going to be x to the 4th minus 49. You're going to hear this question a lot. Just get used to answering it. What is that? It is a difference of two squares. And I get that it's not what you're used to. You're not used to that fourth, but the goal of today is to get you used to those higher powers. That is a difference of squares by definition. Let me ask you a question. What's the square root of what I just circled in red? X squared. What's the square root of what I just circled in green? And if you can identify that that's a square rootable thing, that's a square rootable thing, and that's a minus in the middle, you got work to do. And so what we're going to do is we're going to build our shells. We're going to simply, I'll color code this for your educational convenience. We're going to put the red square root in the beginning of each binomial. We're going to put the green square root at the back of each binomial. And what do we have to have for signs to force the middle term to die? Plus and minus is mandatory. That's what makes the magic happen. And from this point on, as of about 90 seconds ago in this class, it is now officially incumbent upon you, every time you do a step, to look and see if you can do more steps. Can you factor the first one? No, for two reasons. A, it's a plus sign, and B, seven's trash. Can you factor the second one? No. And again, it's trying to trick 17-year-olds into saying yes. 16 and 17-year-olds are going to say, I want to factor that. But you have to be tight. It has to pass all three tests. This has to be a square, this has to be a minus, and this has to be a square. And you can clearly see it fails the third test. 7 is not a square. Therefore, it is done. Got it? Let's go again. X to the fourth minus 1. Again, what I'm trying to do throughout this when I crafted these problems was give you examples that look and feel structurally kind of almost the same, but we treat them differently. First off, what is that thing called? It's a difference of squares. Get used to just saying it out loud, okay? It's a difference of squares. When we factor it, I'm going to ask you the same questions always. What's the square root of the red thing? So you put that here and you put that here. What's the square root of the green thing? So you put that here and you put that here. And what will the signs always be with a difference of squares? 1 plus, 1 minus, right? Is it done? It is not done. Is this factorable, the first one? No. It's a sum of squares. No can do. However, is the purple one done? What is it? It's its own difference of squares, which means the offspring is going to produce offspring. So what we're going to do is we're going to transfer the dead factor down. X squared plus 1, like I said, just hangs around. And then we need 2 shells to compensate for what I've underlined in purple. And that being a difference of squares means you just follow the pattern. What are the factors of x squared minus 1 going to be? X plus 1, x minus 1, problem over. So factoring can and will often take multiple steps. Let's go again. Okay, that's 4 examples. We have 5 to go. The clock's telling me I might not be able to, but I'm going to work you right up to the end here, so stay with me. What is this thing called? What do we have on the TV? What's it called? You just met him today, so I would understand, you know how it is, you meet someone and you forget their name, but we want to become very acquainted with this guy. It's a look-alike. And we know it's a look-alike because we observe the pattern and the powers. That should stick out like a sore thumb. The moment you see even number, half, 0, it's a look-alike. And how we factor a look-alike is we take and we build shells and we treat it just like a quadratic. And you take the first thing that I circled in red, which is 6, and you divide it by 2, which is 3. And you give halvesies here, halvesies here. What are the signs going to be? A plus and a minus because of the 8 in the back, right? The 2 has nothing to do with anything yet. So now we just go through and we think about factors of 8, right? There's not a lot of them. 2 and 4 for the win, for sure. So I'm going to put a 2 here, and I'm going to put a 4 here. And I'm going to check it. You know, if you're still struggling with quadratics, if that's a loose end that you haven't tied up yet, then you're a little bit more lost maybe than the kid sitting next to you. But let's just make sure we're okay. What do the purples on the outside make? Negative 4x cubed. What do the two purples on the inside make? Positive 2, and negative 4 plus 2 is negative 2. So step 1 complete. Do you think that you can factor the green thing? No. It's trying to be something. What's it trying to be? I want you using your words. It's trying to be a sum of cubes. It wants you to think it's a sum of cubes because it passes tests. It says, that's a cube. Plus or minus both work with cubes. But what's wrong with the number 2? 2 is not a cube. Therefore, the first one that I've underlined in green is dead. The second one, what's he trying to be? A difference of cubes. And again, he passes 2 of the 3 tests. We're good there. We're good there. Again, the middle one isn't really a test because the sign can be whatever. Cubes are awesome because you can do them either way. But then you get to the 4 and you're like, 4, you're not a cube. Get out of here. For that reason, the good news is this problem's over. And as you would guess, the next problem is going to be a little different. Do you want to guess what's going to happen in the next example? You don't have to. Here we go. X to the 6th minus 5. X to the 3rd minus 6. What's it called? It's a lookalike, and we recognize it because the powers go even half 0, even half 0. So I'm going to build my shells just like I normally would. Bless you. And I'm going to take x to the half of 6 and x to the half of 6. My signs are going to be 1 plus and 1 minus. Feels like we're just factoring quadratics, right? Nothing to it. What are the numbers we want in this case? 6 and 1 for sure. You are good enough at quadratics. You understand that we don't want 2 and 3. We need 1 to be heavy to make the 5. And so we're going to give the weak to the plus and the heavy to the minus to create the correct balance. Can you factor the one I'm underlining in purple? What's it trying to be? It wants to be a difference of cubes. And yes, it passes tests. X cubed is a cubed. Minus, I don't care. Is 6 a cube? No, it is not. Therefore, that is a dead factor. However, not that you didn't see this coming, the one that I'm underlining in green, can you factor it? What is it? It's its own sum of cubes. Holy Toledo. So this time, one of the offspring of a quadratic lookalike is a sum of cubes. And now I have to go into what we're working on for tomorrow's quiz, and that is, okay, focus on only the red box. Everything else in the problem is going to just wait for us. Now I have to think A and B. What's A? X. What's B? Correct. And at this point now, my answer is going to be, and this is my personal preference. I like to always take the dead roots or the dead factors, excuse me, and put them in the front. This is my choice. You don't have to do it, but what I do is I always take dead ones and I throw them to the left. So I'm going to take my dead x cubed minus 6, and I'm going to pull it out to the left like this. And now I'm going to build a short set and a long set to accommodate the red box. What is short set going to be? A plus B. Nice job. X plus 1. What is long set going to be? Minus plus what? Nice. And that is now a completed product. So don't shuffle, don't pack. Just give me about 30 seconds here. Even those of us that have been doing this a long time, sometimes there's no perfect formula to how to be a high school math teacher. I thought I had enough time to get through 9 examples. I made it through 6. So tomorrow's lesson will be a little bit longer, no big deal. You now know basically, though, the meat and potatoes part of how to factor lookalikes. What you need to expect from this point on is that there's a step and often another step and maybe even another step after that. Are we good? Tomorrow we will start class with notes, and then we will take the quiz, and then we will get to work on assignment 5. In that order, are we clear? If you need help before the quiz, you have lots of opportunities throughout the day today. Please take advantage. How odd to come in tomorrow and not do well when you've had all those chances to seek help.